All right, we want to continue with section 3.2. And again, just to avoid the confusion, the video you watched, that part 2 video, was really from my intermediate algebra class. Don't worry with that. The main thing is you need to make sure you know how to do synthetic division. I'm going to do one more problem by synthetic division, and this will kind of lead us into what else I want to talk about here in section 3.2. So let's do this one right here, divide by synthetic division, right here. And so remember what you do is, in the dividend, you put the coefficients of these. So you've got a 5, a negative 1, a positive 1, and a negative 3. And remember, if there's a missing power of x, you have to put a 0 in its place. Now, the number that goes out front is the opposite of this, which is negative 2. Now bring the 5 all the way down. Negative 2 times 5 is negative 10, so that'd be negative 11. Negative 2 times negative 11 is 22, adds 23. And negative 2 times 23 is negative 46. And subtract that, be negative 49. So when you divide this into this, here is your answer. Now, if you're taking a third degree, biggest power of x, third degree polynomial by first degree polynomial. So the answer is a second degree. So this would be 5x squared minus 11x plus 23. Remember, the number on the end is always your remainder, minus 49, and remember we always put the remainder back over your divisor. Okay, now let me ask a completely different question. If f of x was equal to this, okay, so let's look at this problem right here. So forget this up here. New problem. If f of x is equal to this, find f of k if k is negative 2. So here's basically what this is saying. Find f of k. This is what I want to find. But what do we know k is? It's negative 2. So what does that mean? F of k means find f of negative 2. That's what that means. Now, do you remember the problems you had on your midterm? How do you find f of negative 2? You take negative 2 and plug it into this polynomial right here. Now, you can't find f of negative 2 if I don't give you f of x. So I have to give you this. All right, so how do we find f of negative 2? You're going to put negative 2 here, here, and here. All right, so let's do that. So it's going to be 5 times negative 2 cubed minus negative 2 squared plus negative 2 minus 3. Now let's do the math. Exponents first. 5 times negative 2 cubed. Negative 2 times negative 2 times negative 2 is negative 8. You have to cube first, then multiply. Minus. Negative 2 squared is negative 2 times negative 2, which is 4. Positive, but that makes it go back negative. And then plus a negative 2 is the same thing as minus 2, minus 3. Now, 5 times negative 8 is negative 40. Minus 4, minus 2, minus 3, which is negative 49. So let me write what we just found. What is f of negative 2 equal to in this problem? Negative 49. That's the answer. Now, if you'll remember, I told you this, you may have forgotten it, But I told you this is actually just like an ordered pair. -2, -49. That's what that is. This is your x, and this is your y value. Now, this is what I want you to notice. Let's come back up into this problem. Notice this dividend right here. And notice my function that I gave you. This function is the same as the dividend. Now, notice what k is right here. K is -2. What number is out front right here? -2. Now, how did we find f of -2? We took -2 and plugged it into this polynomial, or into this function. And when I did, look at what answer I got, -49. Now, look at the remainder up here. It's also -49. This is what I'm wanting you to see. When you do synthetic division, I'm going to say this twice. When you do synthetic division with a number, we call that number right there k. Now, when I went through synthetic division, here was the full answer. But look at the remainder, -49. That remainder is the exact same number you would get if you plugged that number straight into that polynomial. Let me say that again. When you do synthetic division with this number right here, we call that number k. When you do synthetic division with a number, whatever your remainder is the same answer that you would get if you plug that number into that function. It's the same number. Let me show you one more. Okay, I want to do synthetic division. So this is going to be 2, 0, 1, -5. Why did I put a 0? Because there's a missing x squared. All right, what number goes out front? 1. The opposite of that. Okay, bring down the number 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. -5 plus 3 is -2. So if I wrote this whole answer out, it would be 2x squared plus 2x plus 3, and then this number right here is the remainder. Now, let me show you what I want you to see. Suppose I had a polynomial that was this. This is the same thing as this up here. Now, let's suppose I ask you to find f of k when k equal 1. Now, how do we do that? To find f of k when k equal 1, that means find f of 1. K is 1, so put 1 right there. Now, how do you find f of 1? To find f of 1, you take 1 and plug it in right here and right there. So this is going to be 2 times 1 cubed plus 1 minus 5, which is equal to 1 to the third is 1. 1 times 2 is 2 plus 1 minus 5. 2 plus 1 is 3, and 3 minus 5 is -2. So f of 1 is equal to -2, which is just simply the ordered pair. Now, you don't have to write it this way. This is the way I want you to write it. But it's the ordered pair 1, -2. So, look at what happened. When you take this number and plug it straight into your function, which was this up here, when you take that k value and you plug it straight into that function, the answer you get out is simply your remainder. This is what I'm wanting you to see. Every time you do synthetic division, you're generating ordered pairs for that function. So if I was to graph this right here, which we are not going to do right now, but if I was to graph y equal 2x cubed plus x minus 5 that we haven't talked about, if I was to graph it, it goes through the point 1 comma negative 2. So, if I give you this, okay, so let me see if you can read all of this. Find f of k, just a second. If f of x equals, I'm fixing to slide this over, so pause it if you need to and copy it. Now copy the rest of it. All right, this is what I'm wanting you to see. There's two ways that we can do it. One is this. Find f of k. What does that mean? F of 3. So one way is to take 3 and literally plug it into x's place right up here and work that out and get that answer. But here's another way to do it. You can do synthetic division, put the k value, which is 3, put it out front, and go through this process. And whatever that number right there is, that is the answer to this problem. So if I say find f of 7, you can do it two ways. Plug 7 into the polynomial, or you can do synthetic division with 7, and whatever the remainder is your f of 7. Now I'm fixing to work an example. What you're looking at right now is called the remainder theorem. Okay, so let's look at an example and let me word it for you like it is in your homework. Write this down listen to me as I read it, and because I'm going to probably go across the page. Use synthetic division and the remainder theorem to find f of k when k equals, just a second, let me make up one. -2 if f of x is equal to 2x to the third minus 5x squared minus x plus 11. Okay, so you're going to have 3 or 4 problems in your homework like this. All right, so let's do the problem, but we've got to do it the way it said do it. So here's how you do it. Read the first 3 words. It says use what? synthetic division. So that means I got to do this. Why? Because that's what synthetic division looks like. All right, now, it says use synthetic division to find f of k. Now, what is k? K is negative 2. That's the number that goes right there. Not the opposite of it. Your k value goes right here. Now, what goes underneath here? Your function. This is going to be your dividend. 2, negative 5, negative 1, and 11. Now, are we looking for the entire answer? Did it say divide by using synthetic division? No. What did it say find? Find what? F of k. So let me come right up under here. This is what we're looking for, f of k. Now, what is k? F of negative 2. This is what we're looking for. So I'm going to put my answer right here. Now, he does not want you to find f of negative 2 by plugging it in. Could you? Yes, you could. I don't want you to, and here's why. He wants you to understand when he says find f of any number, this answer right here is whatever your remainder is. Remember, this is your x value. This number that goes right here is your y value. So we don't want the whole bottom line. We want to know just what the remainder is. That's why this is called the remainder theorem. So f of negative 2 is just the remainder. You say, well, Mr. Randall, will I get the same answer if I plug it in up here and work it out? Yes. Well, could I do that? Would the computer know? No. The computer wouldn't know any different. But I want you to do synthetic division because I want you to make the connection that the answer you get out by plugging that number in is the same number that your remainder is. So all this is just a fancy way of asking this. Tell me what the remainder is when k is negative 2. That's all that's asking. What's just the remainder? Well, let's do synthetic division and see what the remainder is. So bring 2 down. Negative 2 times 2 is negative 4. That's negative 9. Negative 2 times negative 9 is 18. That's 17. Negative 2 times 17 is negative 34. And that's negative 23. So f of negative 2 is just simply negative 23. That's your answer. So when it says find f of k, I've got to do 2 things. I have to tell you what the k value is. That's the number that goes right here. And then when you find f of k is just simply whatever your remainder is. Okay, so that concludes this video. We will do one more video that will close out section 3.2.